REHIS Food Hygiene 2, Bacteria and their Characteristics. At the end of this lesson, you should be able to explain what is meant by the term danger zone, to know what is meant by the term high-risk food, and to know the difference between the terms pathogen and food spoilage. So we're learning where bacteria may be found. We'll be learning about the general structure, shape and size of bacteria, how bacteria multiply, how quickly this may occur and the ideal conditions for multiplication take place. We'll learn what is meant by high-risk food, what is meant by the term danger zone, the formation of bacterial spores and toxins, their function and methods in which they may be destroyed. We'll learn about the terms pathogen and food spoilage. And we'll learn the difference between pathogenic and food spoilage bacteria. We'll learn about food preservation and how the multiplication of pathogens and spoilage organisms can be inhibited by low temperatures through cooking, hot holding and reheating, high temperatures, dehydration, vinegar, vacuum packing, and the use of chemical preservatives. And the last one we'll learn is how bacteria can be destroyed. So, microbiological hazards include the contamination of food by bacteria, viruses, and molds. So, microbiological is a small living organism. So, contamination by food by bacteria, viruses, and molds, or even parasites, and the multiplication of bacteria within food. Often the survival of bacteria and other pathogens are because of inadequate cooking and processing. Bacteria are so small that millions would fit on the point of a pin. One million bacteria can fit on the head of a pin. That's how small they are. You need a microscope to see them. And sometimes we refer to microscopic organisms as germs. So what's the difference between food spoilage and pathogens? A small number of spoilage bacteria cause food to perish, go off, spoil or become unfit, like how your milk goes off and how your bread goes off. You can see the bread going mouldy. Other bacteria such as food poisoning bacteria are known as pathogens. And if a pathogen gets into food, they make people ill. Pathogens have no effect on the appearance, taste or smell of food and can only be detected by testing in a laboratory. So food spoilage bacteria you can smell, you can see it. Pathogens you can't smell or see it, you can't detect it unless you get it tested. And there's different types of bacteria and they vary in shape. Every cell has a cell wall, a nucleus and DNA which help it replicate. It isn't possible to operate a food business without food poisoning bacteria being present at one time or another. It is there in the food. It's therefore essential that we prevent these bacteria from multiplying. We prevent them getting the conditions that they need, which is warmth, food, moisture and time. And if we prevent them getting those conditions, we stop the risk to our customers. So it's important to know the things that bacteria need to survive, and we can then manipulate these in order to prevent multiplication. Bacteria are responsible for causing food poisoning and they need the conditions to enable them to multiply and produce the toxins or poisons Toxins may be released in our body or in the food, and some toxins cannot be destroyed by normal cooking and are very dangerous. So the bacteria need moisture, food, warmth and time. The temperature range in which bacteria multiply is between 5 and 63 degrees. Above 100 degrees, most spore-bearing bacteria are destroyed. Some bacteria slow down between 1 and 4 degrees. Multiplication of bacteria is stopped, it's not killed, it just goes to sleep at below 18 degrees. So to prevent the growth of food poisoning bacteria, you must ensure that the temperature of the food is kept below 5 degrees centigrade or above 63 degrees centigrade. The best temperature for multiplication of food poisoning bacteria is around 37 degrees body temperature. But bacteria can multiply really quickly between 20 degrees and 50 degrees centigrade. The temperature range from 5 degrees to 63 degrees is known as the danger zone, and that's where bacteria rapidly multiply. Most bacteria will not grow in a fridge, and that's between 1 degrees and 4 degrees centigrade. And no bacteria will grow in frozen food at minus 18. At frozen, they will be asleep, and they'll be sleepy in the fridge. They're not killed in the fridge or the freezer. They're only killed by cooking. Many survive being frozen and start multiplying when the food defrosts. Bacteria prefer food to contain nutrients and moisture, especially raw and cooked meat, poultry and dairy produce. Food is categorised into the following groups. High-risk foods, that is foods that are usually rich in protein and are already cooked. Low-risk foods, raw foods that need to be cooked, and then ready to eat raw food. Foods such as dried eggs, milk powder, dried rice, pasta, they do not provide moisture necessary for the growth of bacteria, so bacteria do not grow on them. Time. Given the right conditions of food, moisture and warmth, some bacteria can divide into two every 10 minutes. This process is known as the binary fission. If there's sufficient time, a few bacteria can multiply to such an extent that there's enough present to cause food poisoning. For this reason, it's essential that high-risk foods are not left in the danger zone. That's the temperature range between 5 degrees centigrade and 63 degrees centigrade for longer than is absolutely necessary. In 2 hours, one bacterium can divide and become 2,048 bacterium. 1,000 bacteria can become millions of bacteria within 1 hour and 40 minutes, given the right conditions. Binary fission is the name for when the cells divide. So one cell becomes 2, 2 cells become 4, 4 cells become 8, 8 cells become 16, 16 cells become 32, and so on and so forth. They divide into 2 every 10 minutes. Some bacteria can produce spores which protect them against harmful conditions such as high temperatures, drying and disinfecting. Some spores can survive boiling for up to 5 hours. And it's important that we know the things that bacteria need to multiply so that we can manipulate them in order to prevent multiplication. And if you think of a bacteria spore like a shell round the bacterium, like an eggshell or whatever, round the bacterium, that's what a spore is, and it will help prevent it and protect it from the harmful conditions. And it will only release the bacterium when the conditions become correct. Spores are a resting phase and they do not multiply. The spores release the bacterium when the right conditions return. This process is known as germination. Some bacteria can produce spores when the conditions are unfavourable, and bacterial spores are a dormant, resting state. One example of a bacterial spore is Clostridium botulinum. Botulism Botox is made from this bacteria, which produces a potent neurotoxin which can prove fatal. Its origin is from the soil and risky foods, faulty processes in canned meats and vegetables, cured meat and raw fish. And one of the most common food poisoning is from spore former, which is caused by Clostridium perfringens. Its origin is the environment, and the risky foods are large joints of meat and reheated gravies. Other food poisoning spore formers include Bacillus cereus, which is from rice, and Bacillus subtilis and Bacillus lectin-4. Chilled food storage, as in the fridge, prevent most bacteria from multiplying. It slows down food spoilage, and the fridge temperature should be between 1 degree centigrade and 4 degrees centigrade. With frozen food, there's no bacterial growth. Spores and dormant bacteria will survive the freezer, and the freezer temperature is between 0 degrees centigrade and minus 18 degrees centigrade. The recommended temperature for a freezer is minus 18 degrees centigrade. Thorough cooking will destroy most harmful bacteria. The centre or the coldest part of the food should achieve 75 degrees during cooking, or if you're doing it for a slower one, 70 degrees centigrade for 2 minutes. If you're going to reheat food, it needs to be at 82 degrees centigrade or above, and you can only reheat food once. In the catering industry, you must record the temperatures and the times taken of all the food. This will give you a record which comes in handy if you have an environmental health inspection. High-risk foods are foods which are ready to eat and are cooked, and the cooking destroys the bacteria. Or it could be also foods that are intended to be eaten without cooking. High-risk foods support the multiplication of harmful bacteria. So things could be like cooked meat and poultry, cooked meat products like gravy, stock and meat pies, dairy, milk, cream, artificial cream, soft cheese and custard, eggs and products made from raw eggs like mayonnaise. Mayonnaise is made from egg yolk and oil. It's only 2 ingredients. Shellfish and other seafood like prawns, crabs and oysters. Oysters are often eaten uncooked. And then cooked rice. High-risk foods usually contain proteins. You need to protect them from contamination, keep them refrigerated to prevent the bacteria multiplying, or keep them separate from raw food. Cooked pasta, bean sprouts, jacket potatoes, cut tomatoes and cut melons have all been implicated in food poisoning outbreaks and should be considered as high-risk foods. High-risk foods are often involved in outbreaks of food poisoning. Unfortunately, contaminated foods usually look, taste and smell completely normal and are unlikely to be detected. Raw meat for cooking is not considered to be high risk because food poisoning bacteria will be destroyed during the cooking process. So for low-risk foods, bacteria cannot multiply in dried foods or foods containing high concentrations of salt, sugar, acid and other preservatives. Things like bread, dried pasta, uncooked dried rice, dried pulses and grains, biscuits, jams, canned foods, crisps, breakfast cereals such as your cornflakes or Weetabix, they are all low-risk foods. When water is added to dried foods such as milk powder, it then becomes high risk and must be stored under refrigeration or used immediately. Raw foods to be cooked. You need to keep them separate from ready-to-eat foods, usually on the bottom shelf of the fridge covered in a container, and the food poisoning organisms will be destroyed by thorough cooking. Raw foods are likely to be already contaminated with large numbers of food poisoning organisms, and they must be kept separate from ready-to-eat foods. Ready-to-eat raw foods such as salad or fruit may be contaminated with bacteria and viruses, which only need to be present in low numbers to cause illnesses. You should ensure ready-to-eat foods are washed thoroughly under running water before eating. And you must note that bean sprouts, cut melons, tomatoes, raspberries, spinach and lettuce have all been involved in food poisoning outbreaks. Therefore, you must wash them thoroughly under the running tap. Preservation is the treatment of food to remove or change the conditions required for bacteria to multiply. And there's a variety of them. So there's high temperatures. High temperatures such as 100 degrees centigrade will kill the bacteria. Things like pasteurization, UHT, which stands for ultra high temperature, sterilisation, cooking, canning and bottling. They all use high temperatures. Then there's the low temperature method, but it doesn't kill the bacteria, it just prevents them from growing. So things like keeping it in the fridge or in the freezer, refrigeration and freezing. Dehydration is basically the removal of moisture, and bacteria will not grow without air. Chemicals will stop bacteria from growing. Chemicals that are antimicrobial inhibit bacterial growth, and antioxidants prevent oxidization. Vacuum packing, again that's another one without air, taking the air out of the packaging, and bacteria will not grow without air. Pickling, vinegars and alkaline. Most bacteria grow best around the neutral pH values of 6.5 to 7. So therefore bacteria will not grow in an alkaline environment. Irradiation. Energy from irradiation destroys most of the bacteria. And smoking prevents oxidization, which then also slows bacteria. So your smoking of your meat slows down the bacterial growth. So preservatives such as vinegar is used for things like pickled onions or relishes. Smoking, you could smoke salmon, smoked bacon. Salting, that could be your curing of your ham. And jam making, that's using large amounts of sugar to prevent the bacterial growth in the jam making process. So once opened, the food should be treated as fresh and stored under refrigeration in the fridge. Pasteurised, smoked and vacuum packed meat and fish should also be stored chilled in the fridge. And there should be food safety at all steps, from production to processing to distribution to the restaurant kitchen or shop, and to food preparation and to the customer. Food safety should be at all steps. Food spoilage is food going off. This is not food poisoning. Unlike food contaminated with pathogens, food poisoning bacteria, the effects of food spoilage may change the appearance, taste, texture, odour of food, and then they become unsafe. I'm just going to let you see an example of food spoilage on a strawberry. So as the time elapses, you can see that the strawberry changes appearance. It will change its taste, texture and odour, and it certainly will start to be off and become unsafe to eat. Food spoilage gives it off odours, could be slimy or stickiness, change in its texture, a production of gas, discoloration, mould growth, you saw that with the strawberry, unusual taste, and if it's packaging it could be blown cans and leaking packages. A small number of bacteria known as spoilage bacteria cause food to perish, spoil or become unfit to eat. Food spoilage bacteria is different from food poisoning bacteria. We do not normally eat spoilt food because it smells off and may be slimy or rotten. It signals to us it's not safe to eat. But food that has food poisoning does not have that signal. So above 100 degrees boiling point of water, bacteria could be dead. Most bacteria die at the cooking temperatures. 75 degrees or above destroys the pathogens. So therefore the bacteria will die from 63 degrees and above. Bacteria multiply between 5 degrees centigrade and 63 degrees centigrade, which is the danger zone. They rapidly multiply between 20 degrees centigrade and 50 degrees centigrade. And in the fridge, food spoilage is slow. Bacteria that causes food spoilage or pathogens is either slow to grow or there's no growth, less than 5 degrees. And in the freezer, the bacteria that causes food spoilage and the bacteria that are pathogens, food poisoning bacteria, are dormant. There's no growth below the freezing point. The best temperature for bacteria to grow is 37 degrees. That's body temperature. The danger zone is between 5 degrees centigrade and 63 degrees centigrade, and we should cook food to at least 75 degrees centigrade. The temperature of a fridge in Scotland should be between 1 degree centigrade and 4 degrees centigrade. Raw meat and fish should be kept in the bottom of the fridge covered. And the freezer temperature should be minus 18 degrees. Food should only be reheated once, and the temperature to reheat food should be at 82 degrees centigrade or above. With chicken or meat, a temperature probe or thermometer should be used before cooking. If the item has been frozen, you need to check that it's been defrosted properly. It should also be used after cooking to ensure that chicken or meat has been thoroughly cooked. The probe thermometer should be washed in between to prevent cross-contamination. It's your responsibility to learn about bacteria and how they can be controlled. It's your responsibility to protect the food from contamination and to make sure that spoilt or unfit food is not sold. The law says that chilled food must be stored in a refrigerator or in a cool, ventilated place. Hot food must be stored above 63 degrees centigrade, and reheated food products must reach a temperature minimum of 82 degrees centigrade. How well did you do? Are you able to explain what is meant by the term danger zone? Do you know now what is meant by the term high-risk food? And do you know the difference between the terms pathogen and food spoilage?